All right, this is section 7.1, adjacent and vertical angles. And so we're starting a unit that has to deal with angles and triangles. And before we start, let's review some vocab from your 6th grade year. So we've talked about, we've got acute angles, right angles, obtuse angles, and straight angles are our 4 different types of angles we know so far. And acute angles are angles that are less than 90 degrees, so like a cute little angle. We've got right angles, which are exactly equal to 90 degrees. Obtuse angles, which are greater than 90 degrees, but less than 180, because if it's exactly 180, we call it a straight angle, and 180 degrees forms a straight line. So what we're going to do, to start with, we got 4 different clocks down here, and we can draw these different times on the clock to see which kind of angle they're representing. So the first one I have here is 9 o'clock. And so if we draw those the hour hand and the minute hand, the hour hand, remember, is the shorter one. And it's going to be pointing right at the 9. And then the minute hand's the longer one. It'd be pointing right at the 12 there. So that would be 9 o'clock. And that would be considered a right angle, which you probably could figure that out. That's a right angle. And then we've got 6 o'clock. And so at 6 o'clock, the hour hand is going to be pointing straight at that 6. The minute hand is going to be pointing up at the 12. And that would be a straight angle. And then at 10 o'clock, we've got the hour hand pointing at the 10 and the minute hand pointing again at the 12. That would be an acute angle because it's less than 90 degrees, smaller than a right angle. And then at 3:45, and if you're not careful, you could very easily draw the 3:45 going like this at the 3, and then the 9 obviously being the 45 minutes for the minute hand. But that's not what 3:45 actually looks like. 3:45 is going to be, I agree, the minute hand should be pointing right at the 9, but the hour hand is going to be really close to the 4. Not quite at the 4 yet. But really close to it because it's almost 4 o'clock, 15 minutes away. So at 3:45, we actually have an obtuse angle here, an angle that's larger than 90, but not quite a straight angle. All right, so these instructions actually refer to a picture on the next slide, but I'll go ahead and read it anyways. It says some angles, like angle A, which we'll take a look at, can be named by a single letter. If this does not clearly identify the angle, you should use 3 letters. And you should use capital letters. In geometry, when we're talking about angles and lines and rays and planes and all those, use capital letters. So remember when you're doing your homework over this section to turn your caps lock on or enter capital letters when you're talking about those angles. All right, so this is the picture that I was referring to, and you can see angle A. If I said angle A, everyone's looking at the same exact angle. You can see this right angle up here. This right angle would be angle A. But if I said, everyone look at angle B, well, it'd be difficult to know which angle I'm referring to. Am I referring to this right angle? Am I referring to this acute angle or even this acute angle? Or am I referring to the straight angle, which would be 180 degrees? So it's hard to determine. It's not as easy as it is when I say angle A and you know I'm talking about the right angle. So typically when we're labeling angles, if saying angle A, or in this case angle B, isn't specific enough, we use 3 letters. And so if you look at the instructions up at the top of the screen, it says that angle BDE would be how we would refer to this angle. So angle BDE, B would be the 1 point on the side, angle D would be the vertex, and then angle E is referring to this angle right here that I'm highlighting in green. You can see angle BDE. If I were just to say angle D, it'd be difficult to know which one I'm referring to, but when I say angle BDE, you can draw your eyes from B down to D, and then it said E. So we're talking about that angle there. And so the middle letter is always the vertex, or where the 2 rays meet. So for example, if I wanted to refer to this angle here that I'm coloring in purple, I could say either angle FEB, taking me from F to E to B, or I could say angle BEF, which is the exact same angle, just starting from the other end and going from B to E to F. So I have two ways that I could say that angle. I don't want to say angle E because I wouldn't know which angle I'm referring to, whether it's the purple one or whether it would be the one on this side here. All right, so let's look at this example. It says, use that figure to name each type of angle. First of all, a right angle. And they've already mentioned angle A, and so we could use angle A as a right angle because it meets at 90 degrees. So up here at the top left of our figure. I could also say angle F, or I could even say the angle I just referred to, angle FEB. That would be a right angle because it's on a square here. So angle FEB or BEF, however you want to say it, would also be a right angle. So now example B says an acute angle. In acute angle, we could use angle BDE that they've already got listed for us. So that little mark that I'm putting in front of these letters, that just means angle. And so that way you know you're not talking about a triangle, which also has 3 different letters that you would use. So angle BDE is this angle right here, and that's acute. You could also say angle, another way to say the exact same angle is angle EDB, would be the same exact angle. Or maybe I want to say this angle here that I'm doing in purple. And if I wanted to say that angle, how about angle BDC or angle CDB, however you want to think of it. Okay, so example C says an obtuse angle. And if you're looking up here, you may not see an obtuse angle. However, I am going to use the angle that is made by these lines here. And that would be an obtuse angle, and I just have to label it. So to label it, I could say angle ABD. B is the vertex, it's the middle point. I'm going from A to B to D. Or you could reverse it and say angle DBA, but you're talking about the same exact angle. So that would be an obtuse angle. And then example D says a straight angle, and I'm just going to use the straight line here at the bottom of the figure. There's also a straight line at the top of the figure that you could use. But angle FED or DEF, however you want to write it, could be a straight angle. Or if you wanted to say the angle at the top, angle ABC or CBA would also be a straight angle. So we have all 4 angle types in this figure: right angle, an acute angle, an obtuse angle, and a straight angle. All right, this next question says, how many angles are formed by the intersecting roads? What do you notice about these angles? Well, we actually have 4 different angles that are intersecting here. So I'm going to number them: 1, 2, 3, and 4. So we have 4 angles. And now I'm going to tell you what type of angles they are, because now we're going to get into the vertical and adjacent part of the lesson as it's titled. So we have 4 adjacent angles. And we have 2 pairs of vertical angles. So we have 4 pairs of adjacent angles, and then 2 pairs of vertical angles. So let's talk about what these angles are. Okay, so 2 angles are adjacent angles when they share a common side and have the same vertex. The word adjacent isn't just used in math. Sometimes we'll use that in geometry or really any conversation where you're saying 2 places are next to each other. The word adjacent just means next to. So for example, we could say New Hampshire is adjacent to Maine because it is next to. They share a common border. Indiana is adjacent to Ohio. It's adjacent to Illinois and to Kentucky and to Michigan. It shares a border with these other states. So, and then your next door neighbor, the one that lives right beside you, not across the road, but right beside you, would be adjacent to where you live because you share a common property border, usually a fence. So in this example, you can see angle 2 and 3, or angle 1 and 2, I should say, are adjacent. Even 1 and 4 are adjacent because they share a common side and a common vertex. But I wouldn't say that 2 and 4 are adjacent. I would also not say that 1 and 3 are adjacent. They may share a common vertex, but angle 1 and angle 3 don't share any common sides. That makes them not adjacent. So they share that vertex but not any side. So adjacent means they have to share a side as well. So in this example, let's look. It says name 2 pairs of adjacent angles. And so there's a ton of different ones you could give, but I'm just looking for ones that are next to. I'm just going to highlight this angle here in red, and then in purple I'm going to highlight this angle here. And they are next to each other. They share a common vertex, and they share a common side. In fact, if I highlight them, there's that angle in red, and then the angle in purple, you can see which side they're sharing. It's that AB side that I'm highlighting right here. So there's the common side. So they are adjacent. And so to label them, I would say angle, So I would say angle FBA. That's how I'm going to label that one, angle FBA. And it is adjacent to angle ABC. And remember, I'm using capital letters to label my angles. So those two angles are adjacent to each other. Okay, a second pair of angles, in fact, I could use the same exact angle I was using previously, angle FBA here. And then I could just say that it's adjacent to its other next door neighbor, which is this angle that I'm going to do in green right here. And so angle FBE, or EBF, however you want to say it. Those two angles would be adjacent to each other because they share a common vertex, B, and then they share this common side right there. All right, let's look at a new picture and see if we can do the same thing. Again, just looking at adjacent angles right now. We could say angle, I'm gonna make this a little bit more interesting. How about this angle here? That would be angle MJK, angle MJK using capital letters. And it's adjacent to, I can't pick the angle inside of it. That wouldn't work. It's got to be next to. They can't share any of the space. Just like your property and your next door's neighbor's property don't share any space. They just share a common fence or a common side. But I could say this angle here that I'm doing in blue, that'd be angle NJN, angle NJM, or MJN, however you want to say it. The only way you have to make sure you're saying it is you have to make sure J's in the middle. You can see in both these J's in the middle, it's that common vertex they're sharing. What I couldn't say is angle NMJ. There isn't an angle NMJ. It doesn't make sense. I have to make sure I'm using the correct terminology here. And then another one, let's see. I could say, let's erase this, angle QJK, this angle up here, angle QJK, and angle, let's see, I couldn't pick this angle here because it doesn't share any common sides, but I could pick this angle here, and so that would be angle KJL, angle KJL, or LJK, and those two angles are adjacent. So the last type of angle that we're going to talk about today is vertical angles, and two angles are vertical angles when they are opposite angles formed by the intersection of two lines. So in this example, you can see angle 1 and 3 are vertical angles. They share that vertex, but they don't share any sides. So they're vertical. They're actually right above each other. But that's not what vertical means in this instance. Vertical angles don't mean right above each other. They just mean opposite from one another. So angle 2 and angle 4 are also vertical angles. So in this case, I've got adjacent angles 1 and 2, 2 and 3, 3 and 4. But vertical angles are the ones right opposite from each other, right across from each other. And the special thing about vertical angles is that they are congruent. And that word congruent means they have equal measure. So they are the exact same size. You can see when they labeled them, they did angle 1 and 3 with 1 red mark, and angle 2 and 4 with 2 red marks, showing that the ones with 1 red mark are equal, and the ones that have 2 red marks are equal. So let's look at these same pictures we did in the last problem, except this time we're going to try to see if we can find vertical angles instead of adjacent angles. And so vertical angles, we could start with this angle here. That angle is vertical from this angle here. They are right across from each other. They're also the same size. So I would say angle FBA and angle CBD is just one way I could list those angles. And then I need another pair of vertical angles. So what I'm going to do is I'm going to ignore this little line right there, the little ray, and I'm going to say this angle and this obtuse angle, not including that squiggly line that I made. So ignore that E for a second. Angle ABC is vertical from angle FBD. FBD. So if I were to cover that up, in fact, I might see if I can do this real quick. If I just cover this up, you'll know exactly which angle I'm referring to. And if I cover that up, you can see that they're congruent now. Angle ABC and angle FBD. And in the next one down here, also looking for two pairs of vertical angles. How about this angle here and this angle there? They would be vertical. So angle PJQ and angle LJM or MJL, however you want to say it. Those two would be vertical. And then I could say these two little angles here, these two little cute angles here that I'm doing in yellow, angle PJN, and angle KJL, are vertical and therefore congruent, which means they're the same size. Okay, this example says tell whether the angles are adjacent or vertical and then find the value of x. So we have to know these definitions of adjacent or vertical in order to be able to find the value of x. So in example A, these two angles, the x degree angle and the 70 degree angle, are right across from each other. You would say they're opposite from one another, and so that makes them vertical angles. And so we know vertical angles are congruent, and that means the same size. So if they're congruent, that means x is also going to be 70 degrees. So x equals 70. In example B, these two angles share a common side. They are not opposite from one another. They are next to one another, and that means they are adjacent angles. They share that common side there. So they are adjacent. And so being adjacent doesn't mean anything special. It just means next to each other. It doesn't mean they're the same size like vertical angles are. But these two adjacent angles together form a 90-degree right angle. So if I erase this purple line, you actually see that right angle measurement right there, that little red box, which means it's a right angle. And so because they're right next to each other, I know that together these two angles will add up to 90 degrees. So I'm going to make an equation that shows that they will add up to 90 degrees. And so to do that, I'm going to say that the x plus 4 angle plus the 31-degree angle together will equal 90 degrees. And we're just going to solve this equation for x. The first thing you would do solving this equation is you would combine those two like terms, the 4 and the 31 there. They're both positive. So we're going to combine those together to get x plus 35 equals 90. 31 plus 4 is 35. And then we're going to subtract 35 from both sides to get x by itself. And so 90 minus 35 is 55. So we know they're adjacent angles, and we know because they're adjacent and they make this right angle together, that x has to be 55. In example C, we see that these are also going to be adjacent angles because they share this common vertex right there. So I know they're adjacent. And this time, together, they won't add up to 90, but together they form a straight angle. And since we know a straight angle measures 180 degrees, then these two angles together will add up to 180. Again, adjacent just means that they're next to each other. That's not telling me why they add up to 80. The reason why they add up to 80 is these two adjacent angles together form a straight angle. And so if I subtract 85 from both sides, I'll get x equals 95. So the measure of angle x has to be 95. And then you can check your work. Does 95 plus 85 equal 180? It absolutely does. And then in example D here, these two angles are across from each other. They're opposite from one another, so we are going to say that they are vertical angles. You can see this angle X here, and then the right angle. And remember that vertical angles are congruent. So whatever the one of the angles is, the other angle is the exact same because they're vertical, not adjacent, but vertical. So if one angle is 90 degrees, so will the other angle. So X has to be a 90-degree right angle. All right, last example like this. These two angles are right next to each other, so we are going to say that they are adjacent angles. And again, together they are forming a 90-degree angle. So the fact that they're adjacent means they're just right next to each other, but the fact that that's a right angle that they both form means that together they will add up to 90 degrees. So 69 plus 2x minus 1 adds up to 90 degrees. So just like before, I'm going to combine my like terms. My like terms in this case are my constant terms. I don't have more than one variable term, but I do have more than one constant term on that left side. And so 69 and negative 1, different signs subtract, makes 68 plus 2x equals 90. Now we can get rid of that 68. It's a positive 68, so we're going to subtract 68 from both sides, make it go away, leaving us with 2x equals 22. That's what 90 minus 68 is. And then now finally we can divide by 2. And if we divide by 2, we find out that 2 goes into 22 11 times. So they're adjacent angles. Together they form that 90-degree angle, so x has to be 11. And if I plug in my answer, I can double check. 2 times 11 is 22. Minus 1 is 21. And 21 and 69 together will make that 90-degree angle. All right, let's look at some homework questions. Number 21 here, it says, determine whether the statement is always, sometimes, or never true. It says, when the measure of angle 1 is 70 degrees, the measure of angle 3 is 110 degrees. So if the measure of angle 1 is 70 degrees, then the measure of angle 3, well, let's see here, the two angles that we're referencing, angle 1 and angle 3, are vertical angles. And we just learned that vertical angles are congruent, which means equal measure. So if the measure of angle 1 is 70 degrees, the measure of angle 3 would also have to be 70 degrees. So this would be false. This is never true. Angle 1 and angle 3 have to be congruent. In fact, angle 2 and angle 4 also have to be the same size. Number 22 also is a always, sometimes, or never true problem. It says if the measure of angle 4 is 120 degrees, so 120 degrees, then what's the measure of angle, or it says the measure of angle 1 is 60 degrees. Well, these two angles, angle 4 and angle 1, are adjacent angles, which means they're next to each other. They share this common vertex, or this common side and vertex. So they're adjacent angles, but however, they also form this straight line right there, or that straight angle. And since we know straight angles measure 180 degrees, the measure of angle 1, which is 60 degrees, plus the measure of angle 4, which is 120 degrees, has to add up to 180. And again, I know this because together they form this straight angle. They're right next to each other, and angle 1 and angle 4 have to add up to 180. So because 60 plus 120 is 180, this would always be true. If angle 4 is 120 degrees, angle 1 would have to be 60. In fact, angle 3 would also have to be 60 because they also form a straight angle. Number 23, angle 2 and angle 3 are congruent. Well, in the picture that we have, I would say definitely not. Angle 2 is obtuse and angle 3 is acute, so there's no way they can have equal measure, which is what congruent means. But if I were to tilt these lines a little bit and make them look like this, so that they're perpendicular, perpendicular lines intersect at right angles. So if I did that, then, oops, this would be 4, 3. Then angle 2 would be 90 degrees, and angle 3 would have to also be 90 degrees. In fact, they'd all have to be 90 degrees. So I guess there is a way for them to be congruent, but it's only if they're perpendicular lines. So not all lines are perpendicular. So I'm going to have to say this one is sometimes true. But in most cases, you're right, angle 2 and angle 3 would have to be different sizes, but it could be perpendicular. And number 24, the last one here, says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. So angle 1 and angle 2, if I add them together, because they're adjacent and together form this straight angle that I'm marking here in purple, I know that angle 1 plus angle 2 has to be 180 degrees. They form a straight angle. And then angle 3 and angle 4, which I'm going to circle down here, angle 3 plus angle 4, they also form a straight angle. They form that same exact angle just on the bottom side. So they're also equal to 180 degrees. So when it says angle 1 plus angle 2 equals the measure of angle 3 plus angle 4, that would be always true.